Welcome back. This is Mrs. Rubright with Advanced Algebra 1 Honors. Today's lesson is 1.8, Rates, Ratios, and Proportions. Alright, so, unit analysis. When evaluating expressions that represent real-world situations, you should pay attention to the units of measurement attached to the parts of the expression. For instance, if P people go to a restaurant and agree to split the $50 cost of the meal equally, then the units of the numerator of the expression are 50 over P, or dollars. The units in the denominator are people. The units for the value of the expression are dollars per person. When you're doing division or a fraction, it's per. So it's $50 per person. 50 divided by the number of people will tell you how much per person. So in this scenario, did they say how many people were going to dinner? No, they did not. So if there were 4 people, it would be 50 divided by 4 would be $12.50 each, right? Sheila is participating in a multi-day bike trip. On the first day, she rode 100 miles in 8 hours. Use the expression D over T, where D is the distance traveled and T is the time traveled, to find her average rate of travel. So we're going to find her miles per hour. Include the units when evaluating the expression. Okay, so she did 100 miles in 8 hours, per 8 hours, right? So that is going to reduce to 12.5 miles per hour. MPH stands for miles per hour. You can also just write out miles per hour. I'm good with either way. If Sheila continues riding at her average rate for the first day, then the expression 100 plus 12.5t gives the total distance that she traveled after riding for t hours on the second day. Evaluate this expression when t equals 7 and include the units. So 100 plus 12.5 times 7 . Oh, they want us to put the units. 100 miles plus 12.5. 12.5 is what? Miles per hour, right? Times T. What is T? 7 what? Hours, right? Times 7 hours equals. So we have 12.5 times 7. Take out your calculator. 12.5 times 7, 87.5, plus 100. 187.5, and this is in miles. Why is it in miles? Well, think about this. I'm going to write this in a way that actually makes more sense. So we had 100 miles plus 12.5 miles per hour times 7 hours. Do you guys see how these hours are diagonal from each other? They cancel each other out. This is per 1 hour. The hours cancel each other out, leaving you with miles here. And you're adding miles plus miles is going to be an answer in miles. You guys kind of see how that works? What terms in the expression 100 plus 12.5t, what are the terms in the expression? Okay, so we have 100 is one of the terms, right? And 12.5t is one of the terms. What does each term represent in the context of her bike trip? So the term 100 represents the distance in miles that Sheila traveled on the first day. The term 12.5t is the distance in miles that she traveled on the second day. What is the coefficient of the term 12.5t? The coefficient is the number in front of it, right? So 12.5. What does it represent in the context of her bike trip? It represents, what do you guys think it represents? Her speed, right? Her average rate of travel in miles per hour. Her speed, or average rate of travel in miles per hour. So the distance she's traveled is the 100 miles from yesterday plus 12.5 miles per hour today is the total distance that she has covered. Okay? If you write only the units for the expression 100 plus 12.5t, you get miles plus miles per hour times hours, where mi is the abbreviation for miles and h is the abbreviation for hours. Explain what the following unit analysis shows. So once again, the hours are canceling each other out, leaving miles plus miles equaling miles, right? It shows that those hours cancel out. So when you multiply miles per hour by hours, you get miles. When you add miles to miles, you get miles. Right? They canceled each other out. How can you modify the expression 100 plus 12.5 times the number of hours so that the units are feet when the expression is evaluated? So if we wanted the units in feet. So, how many feet are in a mile? 5,280 feet per 1 mile, right? So if my answer is in miles, right? So if I have my answer in miles, can't I multiply that by feet over miles so that the miles will cancel out? So 5,280 feet per 1 mile, and then my answer would be in feet. So I take my problem here and I just multiply it by 5,280. So 5,280 times the 100 plus 12.5t would make my answer in feet. Does that make sense, guys? So if we had miles, we'd have to times feet over miles to get out of miles and into feet. When you're getting out of something, it has to be diagonal so that it cancels out. And that's called dimensional analysis. Using unit analysis to guide modeling. Lizzie has volunteered 20 hours at her town library. From now on, she plans to volunteer 5 hours per week at the library. Write an algebraic expression to represent the total number of hours she will volunteer. Okay, use dimensional analysis to help you get the correct units of the expression. So if we have hours plus hours per week times something, we want our answer to be in hours. We need to multiply by weeks, right? Because then the weeks would cancel out. And we'd have hours plus hours equaling hours. So we have the hours already worked plus hours per week times the number of weeks worked in the future. All right, so let W represent the weeks worked in the future. So to write an algebraic expression for this, it would be the 20 hours that she already worked plus the 5 hours per week that she will work times the number of weeks that she will work. Explain why you chose to use the units you chose in Part A. So, the product in Part A has to be hours to get hours plus hours equaling hours, right? We needed it to cancel out. We need the weeks to cancel out. In order for weeks to divide out and hours to remain, you have to multiply hours per week by the number of weeks worked in the future. Give you guys a second to finish copying this. How many hours will Lizzie have volunteered at the library by the end of 10 weeks? So how many hours did she already previously work? She worked how many hours? She worked 20 hours already? And how many hours is she going to continue working? 5 per week. Times how many weeks? Times 10 weeks. So that's 50 hours that she will work, plus the 20 she already worked is 70 hours. Lizzie has also volunteered 10 hours at an animal shelter, and she plans to volunteer there 3 hours a week beginning in 1 week. Rewrite the algebraic expression you wrote in Part D above based on this new information. Assume that the number of weeks is at least 1. Simplify if possible. All right. So, what does she have already? She has 20 hours plus 5 per week. That's her library. Plus 10 hours that she already volunteered at the animal shelter. Plus 3 per week starting in 1 week. So minus 1. The number of weeks minus 1 because she's not doing it this week, so we have to subtract 1 week, right? So if we wanted to simplify all this and combine like terms and everything, the first thing I'm going to do is I'm going to distribute. And I would have 10 plus 3w minus 3. plus 20 plus 5W, right? 5 W's plus 3 W's, 8 W's. 20 plus 10 is 30, minus 3, plus 27. 8W plus 27. Or 27 plus 8W, either order, right? So she's already worked 27 hours, and she's going to continue working 8 hours per week. 5 hours at the library and 3 at the animal shelter. Make sense? How many hours will Lizzie have volunteered at the library and the animal shelter combined at the end of 20 weeks? Well, 8 hours per week times 20 weeks plus the 27 hours she already worked. Technically, it was 30 hours she already worked, but we can't include those 3 hours that she didn't put in at the animal shelter that first week, right? So 160 plus 27 is 187 hours. Let's do a couple examples. Henry drives in town at a rate of 25 miles per hour. It takes him 15 minutes to go to the library from his house. The algebraic expression RT represents the distance traveled, where R is the average rate in miles per hour, and T is the time that he's traveled. So how fast he's traveling times how long he's traveling equals the distance he's traveled, right? Can you multiply 25 and 15 to find the distance he's traveled to the library? Well, let's see. So this is his speed, 25 miles per hour, times 15 minutes. Is hours and 15 minutes equivalent? Would those cancel out? No. Can I go 15 minutes? No, these two units need to be the same. So I'm going to have to do a conversion first, right? No, the units do not match. You must convert 15 minutes to hours first. Show how to find the distance from Henry's house to the library. Include units in your calculation. All right, so we have to convert the 15 minutes into hours. 15 minutes times, minutes need to be diagonal to cancel out, right? 60 minutes in 1 hour. This will convert it into hours. 15 divided by 60 is 1/4. So now, if I did 25 miles per 1 hour times 1/4 or 0.25 hours, right, equals what? Well, the hours are gone. What is 25 times 0.25? I get 6.25 miles. You see how I did that? 6.25 miles. Is everyone okay on that? Yeah? Good. You guys remember this? You hit on it very briefly in middle school, right? And I believe it's 7th grade, and then a little bit in 8th grade, you guys should have done some dimensional analysis. Also, it's covered in chemistry and some other science courses, so you might have had it in science already. If not, you will. Science works 4 hours her first week of a part-time job and earns $60. Her total pay after the second week can be represented by the expression 60 plus P over T times S. This is our expression. What is an expression? Expression doesn't have a what? No equal sign. An equation has an equal sign, an expression does not. Where P represents her pay for T hours of work, and S represents the hours she worked in the second week. Okay? She earns $60 plus her pay divided by the number of hours, so her hourly rate, the money per hour, times S, the hours that she works in the second week. So her hourly rate times the hours she works plus the $60 she already has, right? What are the units of the fraction? That would be dollars. The pay is in dollars. Per what? What's T? Hours. So dollars per hour. Rewrite the expression substituting the given values for P and T. What are the units of each term in your new expression? So you have 60 plus, you have your dollars per hour times your hours, number of hours, right? So the hours would cancel out, and your 60 is dollars, right? Isn't this dollars? You'd have dollars plus dollars, which was going to equal dollars. So it would be 60 plus 15s. Where'd I get the 15? She worked 4 hours her first week. She made $60 for 4 hours. $60 divided by 4 hours is a rate of $15 per hour. $15 per hour plus the $60 she already made. Does that make sense? Do you guys get that? She has $60 after working 4 hours. 60 divided by 4, she made $15 an hour. So her current rate is $15 an hour times the number of hours she works plus the $60 she already made. Are you guys seeing that? Evaluate your expression for S equals 5. So she already has $60 plus she's making $15 an hour for 5 additional hours. 15 times 5 would be $30, $60, $75 plus $60, $135. Is this making sense? We're good? All right, guys. Well, I hope you enjoyed this lesson. Please like and subscribe and have a fantastic day. Your homework is page 51 and 52.